quality, extra strong Roman concrete,
fully hydraulic,
structural solid connections.
It's the
structural
Engineering podcast.
Hello, everybody. Welcome to this week's episode of the Structural Engineering Podcast. We're pretty excited for this one. We got a lot of cool changes going on. If you're watching on YouTube, you might notice that the camera is level. If you're listening to us, you might notice that the microphone works. So this is, we're making big leaps.
We're really invested in this podcast with the traction we've got.
Yeah. We got 6-ish followers. We figured we'd each put down $10 and get a microphone. So, welcome. We're also kicking this one off with a little bit of structural engineering news.
We're trying to be a little more structured with our podcast.
Ooh.
Yeah. Yeah.
So we got correspondent Zach in the field.
I'm here out in the field.
Tell us what's happening.
It's really windy.
In the news this week.
Yeah, this one's been in the news for a little while, but I think it's a good talking point. It's the Salesforce Transit Center in San Francisco. Do you know anything about this topic?
I know what Salesforce is.
What is Salesforce?
It's a business.
All right, sounds good. So that's where we'll start this off. This week we only have this one news story, but it's pretty big. So at the Salesforce Transit Center, they have an 80-foot span girder, which has a point load at mid-span that is hanging the bridge deck below. And it is more or less a bridge girder because it is spanning a whole roadway.
Hold on. So there's a very tall building, or a tall, how big is it?
This is a transit center. I think it's 3 or 4 stories.
Okay, so not huge, but underneath it is holding up a road.
Yeah, for buses, for transit. So these girders are hanging the transit way through because they don't want columns down the middle of the road.
Jeez, okay.
And they want to keep head height and stuff so there's not massive girders and all these things. So these girders are 8 feet deep, 4-inch thick flanges.
Huh.
Massive. So they found a little while ago some massive, or some fissures, some cracks.
Really?
It's all cracking and everything. So it's starting to look like it is actually a design flaw.
Oh, really? I was going to say a temperature issue, like when they assembled these things.
So it's good you brought that up. That was the first idea.
Okay.
First idea. The fabricator.
I would have been dropped at the first.
Yeah, so that's what's been in the news for the last couple of weeks is it's a fabrication error. And that's exactly it. Not enough preheating, all this stuff with the welds. So there's these cracks at mid-span. Well, what they did, to understand the connection a little bit, is they cut out a part of the flange and ran a plate through the flange, and then they took out some of the web and they ran it up, so it became the web. Yeah. And then they welded that in. And the web is many inches thick as well. They did that and they added stiffeners there as well. This is more or less, bridge girder that is here is more or less a big wide flange. Mm-hmm. Big wide flange. 4-inch flanges, probably 1 to 2 inch stiffeners, and then that plate comes through vertically from the bottom.
Okay, I got you.
Well, from many experts within the field of bridge engineering says this is a horrible detail. They had areas open for welding. There were some holes left in certain areas to allow welds to be placed, but they weren't backfilled, and issues like that. So they're still working through it. The fabricator now is saying it is an engineering failure.
Oh, no.
The industry of bridge engineering is stating that they believe it is also engineering failure. Although those expert engineers don't want to be named.
Yeah.
So take it for what it is there. But I think it's a really interesting thing. Right now they have it jacked up. So they have.
Is the bridge obviously closed at this point? Or what's going on? Is the road jacked up? Or the beam is jacked up?
The beam
just
is
to hold
jacked
it until they figure it out?
Correct. Yeah. So there's a...
What is it jacked from? If it's hanging on a road, are they not jacking from the road? They went underneath the second road and jacked
I don't think the second road's in place yet.
Oh, okay.
I'll get back to you on that. But they've jacked it up and they just this hanger and more or less what the industry is saying is they should have brought the hanger up and then brought it into the webs rather than through things. So these cracks are happening on the flanges. So they put a big slot in the flange.
I didn't even know that was a failure that you would see.
the big reason they're saying the big thing they're saying is that how it is a bad detail is it doesn't work with fatigue loading. So think of it that way: a vehicle coming through, and that thing bounces a little bit.
So it's already
It's
fatiguing.
got this crack. It's already fatiguing,
which should be thousands of cycles, and it's there already.
Yeah. Yeah, so it's fatiguing, it's cracking. They've stripped all the fireproofing off it. They've done tons of testing. This is millions of dollars.
Wow.
So, that's the biggest thing in the news.
That's
crazy
cool.
thing is the way they found out about the cracks is the fireproofing was separating
That's a pretty big crack.
on the girders. Yeah, so it was it was obvious from there.
Wow, man.
Bottom flange crack. So, yeah, could have been pretty bad.
That's wild. I was looking at a lot of structural failures last couple weeks for some things, and there are a lot of engineers at fault when that happens. Like, I wanted to think, looking into it, that it was mostly fluke or construction errors. There's a lot of, miscalcs and overthought.
I think there needs to be a lot more review on things, especially like this. I think bridges, you see this a lot in.
Yeah.
And recently, especially with the one in Florida, they're coming to find out that they believe it's an engineering thing.
Really?
as well.
I was just looking back in on that because
Yeah.
it disappeared from the news, of course, once it's not brand new.
Yeah.
Yeah.
It's going back and forth, though.
Okay. Yeah. The last thing that I saw was that it was the one of the members that initially failed
Number
was
11.
was under reinforced or something like that.
Yeah.
Like engineering failure. Yeah.
Yeah, and that firm has bridges all over
Yeah.
Florida.
And a good record.
Yeah. So I think part of the issues with that Florida bridge was the type of construction they used. They used
You
a
think
thing
the
called
rapid construction?
ABC.
Yeah.
Accelerated bridge construction, and I believe not only did that in this case, if it became a design flaw,
Yeah.
it'd be a little different, but I think they were also making the design go quick too. So the rush of the design, rush of construction, the engineer, from what I read, was there the day that it collapsed and said the cracks that were there were okay.
But you know what? If you see cracks in concrete,
These cracks you could almost put your hand in.
that's a pretty big crack.
Brand new bridge.
Okay. I'm thinking,
Or maybe-
from the news
maybe I
article,
hand.
they said crack, and I was like, well, yeah, of course.
I'll show you after
cracks.
this podcast. They're probably a 1/4 inch.
All right, that's a big ratio.
Brand new bridge.
Yeah.
Yes, over time you see cracks are pretty tight usually.
Well,
though.
still, when I read that, I was thinking, like, they had to move this thing into place. It probably was going to crack a little bit.
Mm-hmm.
So I was thinking these were like hairline cracks, and the engineer said, yeah, that's totally normal. But maybe that's not the case.
I'll show you the cracks later.
All right.
We'll talk about it next week.
Cool.
Or in our next podcast. But for this week, the Salesforce tower girders, or not tower, sorry, the Salesforce
Hanger.
Transit Center
Awesome.
girder. So
That's a news story and a half. Not bad.
Story.
Touching on another. Okay.
Really kicking it off strong.
Awesome. Thank you, correspondent.
Yes.
And now let's get into the podcast.
And I'll fly back in later for the podcast.
What's our podcast topic this week?
OSB versus plywood.
Ding, ding, ding.
Yeah. Yeah. Ding, ding, ding. Watch us box it out on this topic. This is gonna be a more informational podcast, I think. I don't think there's too much to debate.
We're going to try our best to debate.
Yeah, but it's more of a podcast so you can sit and listen on your way into work or at work and understand why you'd use one or the other, a little history behind, and what to spec maybe.
Yeah,
What
I've
to
definitely
use.
gotten this question a handful of times, and they're spaced out enough that I always kind of forget. Like, I know the overall answer, but this is nice, digging into it a little bit, knowing the actual difference.
Yeah.
And now I just will know the answer. It's over. It's done.
I like it. Well, you want to kick it off with a little OSB?
Yeah, so what I found is OSB is better. You want to take it from here?
It's not better. Plywood is superior because they make airplanes out of it.
OSB makes up 70% of the current housing stock. What do you think of that?
It makes sense.
It's cheaper.
It's cheaper.
A lot.
It's a lot cheaper.
Can be. I feel like we should organize this in some order here, but let's start by saying that they're basically just as good. Like, they are structurally, when all conditions are working well, the same, more or less, product.
I don't think you can say more or less. I think we have to be definitive.
Oh, they have the same. Well, here's the thing. Okay. In the code, they are the same, and that's what matters.
Yeah.
OSB is twice as stiff in shear as plywood. Boom.
Why do I care?
I don't know. It doesn't matter.
If I'm using the same shear forces.
You're using the same shear
But
forces.
when I calculate deflections.
Deflections will be tighter.
Yeah.
In OSB. OSB is a lot stiffer, but apparently that nails become the bigger issue with OSB. Pull through and pull out or whatever.
Mm-hmm.
Hold on. We're organized here. How is plywood made? You tell me. I'll tell you how OSB is made.
Okay. Yeah, I'll tell you.
Yeah, you tell me.
So it's composed of 3 millimeter, about 1/8 of an inch layers of wood. Mm-hmm. And they are layered, they're cross laminated. So each layer rotates 90 degrees. And they go from 1/8 of an inch, so just one layer, up to 3 inches thick.
That's very thick.
And they're glued together and compressed.
Interesting. So, I'll throw in with plywood because I was searching this when OSB came in. So it is always symmetric. So the last and first sheet have to be facing the same direction in order to have the centroid in the middle.
There's always an odd amount of sheets.
There's always an odd amount of sheets. What that means.
And the top and bottom sheets are the highest grade of wood.
Yeah.
And the middle ones aren't, so that it has more strength in bending.
Sort of, but I did see in one of these articles that the sheets can be selected randomly. So I guess you could have heartwood or early wood kind of anywhere, but I have elsewhere seen that the exterior is always the best. But I wonder if that's...
So it's dependent on grade.
Okay.
There's different grades. There, I think, is about 8 different grades of plywood.
Oh, goodness.
So you just want the best grade.
Get the best grade. What's that, structural 1? Structural 2?
Select structural.
Select structural.
Yeah.
Okay. And they're glued together. All right, so much like OSB... Right, OSB is made from, it's oriented strand board. It's made from a bunch of pieces of lumber, all squished together. They basically make this giant chipper, and they dry these pieces of wood out, and they make a pile of them, and they orient them in one general direction, and they alternate like they do on plywood. So you'll have a layer going one way, and then a layer going the other way. It's 5 to 8 inches thick. They put a bunch of wax and glue, heat it up to like 1200 degrees and squish it. What that gives you is a totally homogeneous product when you're looking structurally that is basically stiffer. It's I guess it's sort of less stiff, but it's more the range of stiffness is much, much smaller. There's no soft spots like if in plywood you could have overlaps of knots and whatnot. So it's kind of more of a waste product. It can be made, it seems greener, in a sense, like it can be made from fast growing wood. It doesn't have to be as strong because it's more consistent.
Yeah. That makes sense.
But
do they make airplanes out of it?
Yeah. Big ones. No, I don't think they do.
In World War II, they started making, is when more or less they started making aircrafts and boats. They started using a lot in the marine world. Really?
That's cool.
Yeah. They also make wind turbine props out of it.
Are they waterproof, these fancy ones?
Some of them are.
Really?
Yeah.
That's pretty cool.
There's different, they do a lot of different coatings and things like that.
What are your downsides?
That's too good?
Yeah.
Yeah.
I get that all the time by myself.
Yeah.
Never.
The good things are also the bad things. No, I think one of the biggest things that it probably does, it's more expensive than OSB, but it does not shrink.
Yeah. That's a plus. We're not talking
since
we're
going opposite
what are your Nothing. It's too good.
I think cost is really one of the biggest things. It's just too expensive.
Yeah.
It now like OSB, if it gets moisture, it gets sort of just mostly the edges will
the sort of halo
thicker.
thing. They had a better name for it, but the edges.
Now
thicken.
plywood, the whole thing saturates.
The whole thing saturates, but it dries and absorbs faster.
Correct.
And the absorption doesn't matter. It's the drying.
It's the drying, absolutely. So I've been on job sites. Maybe this is where a little bit of our experience goes in with OSB, and it's swelled up.
Yeah.
And so that's where they had to replace it. Yeah. They had to rip it off and replace it because How do you justify shear values of plywood on a shear wall if it's now 3 times its thickness, or twice its thickness?
It's twice as strong. All right,
gaps help.
Let's go into my.
I guess your moment of inertia would be greater. Really
wouldn't hold together at all.
Wouldn't hold together.
All right, let's talk about the negatives of OSB, because there's a lot, which is a bummer. It's a lot cheaper, which is a positive, obviously.
And I would say that's why she's on houses.
A lot, yeah, and that's why it's used everywhere. It's not a lot cheaper. It's a couple bucks a sheet, but when you're looking at several thousand square feet, it can be many $1,000s.
Yeah,
absolutely significant. But like you had mentioned, so water absorption, it absorbs water very slowly. That's cool, but it hangs onto it forever.
Yeah,
and that's a problem. And one of the issues that they have are the edges absorb a lot quicker, of course. Mm-hmm. So you get sort of a halo where the edge of the board expands and the center doesn't, and it starts to lift things. So for tile, like the National Tile Association says no OSB.
Yeah,
because you're going to start to lift things unevenly. It's not about the stiffness. It's about what happens when it gets wet.
It's just because plywood's better. Question, do you know?
Yeah.
And I don't know this off the top of my head. And I wish I looked this up before we started recording, but what's the weight difference? Same thickness.
OSB is a little bit heavier. How? Not much.
Like what? 5%?
I'd say about 5%. In a 3/4 inch sheet, there was a difference of a few pounds from what I remember. I did read this, but I don't remember the total numbers.
A few pounds per square foot or per sheet?
Per sheet.
Okay.
Per sheet. Yeah,
okay.
Yeah.
I was like, per square foot?
No. But those things, I mean, it's a heavy sheet, so adding like 2 pounds is nothing.
Right.
But yeah, OSB is heavier, definitely. Let's see. More okay. So other negatives. For this halo effect, they do treat the edges now, so the edges don't absorb water as much. But in reality, on a construction site, you're not always using a perfect 4x8, so there's a lot of cuts going on.
Right.
And those cuts then aren't treated. So now you have a perfect spot to absorb more water. That's already been kind of flared and damaged maybe by a saw and more likely to absorb some water. You know what I mean?
Oh, yeah. I know what you mean. When was OSB invented?
Not that long ago. I read an article from 2005 and it said 14 years-ish before that. So
plywood initially was created in 1797 by a British naval engineer.
Oh, so you're saying it's more old-fashioned, kind of going away sort of thing.
No, I'm saying it is here to stay and it is superior. That's how you know, because it costs more money.
I did see that when plywood was first invented, so there wasn't waterproof glue, I guess, until after World War I, or not for a long time. Glue was made from horse hooves and blood, apparently.
Yeah.
Yes.
Gummy
bears mostly. Oh yeah, I like those.
Yeah.
No blood in them. It's the blood that's bothering me, not the horse hooves.
Oh.
All right, but plywood got a bad rap because it would separate as well. And then forever, so before World War I, contractors would only use like this lath system, like solid boards. Yeah. Like big, as thick as they get, which makes sense. And so when there was a switch to plywood, people said, oh, this is not a good product. It can fall apart, and it was falling apart, which is the same when they switched to OSB. It's like it was falling apart. They didn't have it quite down yet. Yeah. But
they learned from their failures.
And now OSB is the better one.
That is debatable.
You would definitely get a question. I feel like
how's your shrinkage?
Oh man, I got a lot of shrinkage. That's a good point.
So your boards aren't your sheets aren't very dimensional, are they?
No.
So
no.
What is that? Why is that an issue?
Because it shrinks.
Yeah.
I mean, you get gaps.
You get gaps? How easy is it to fit up when they're building it if it's all different shapes and sizes?
Well, I think the shrinkage is a little more long term than that. Like once it's fit
up.
What
if they had some older?
Yeah, you're gonna have more shrinkage with OSB, no doubt.
Yeah. So plywood, there's a whole bunch of different types of wood they use. Without going into the species, softwood, hardwood, tropical woods. Tropical woods is mostly in Africa, South America, that they use. It more or less, like in the U.S., we have soft and hardwoods, fairly well defined.
Yeah.
And then tropical, you start getting to other countries that have different wood than the U.S., and that's why they start calling it tropical. The softwood...
Couldn't think of anything else.
They couldn't find any other word. Yeah. So tropical wood.
Tropical punch.
Tropical plywood. The soft plywood is typically what they use for walls and roofs of houses.
Okay.
Is the most common one used when they're using plywood, not OSB.
Just like a pine.
The hardwood is like legitimate hardwoods that you'd use for maybe making a table or something like that.
Like an oak.
So majority of the hardwood plywoods are used for like high quality speakers and things of greater quality. I think that was the biggest one I found was the speakers that they used it for.
I could see how you would want. So hardwoods would be oak, walnut, teak, maple, and then a whole bunch.
Which
of
I would love
stuff.
to see a sheet of.
Oh man, I bet that's some heavy stuff.
Maple plywood. It's got to be pretty.
That makes sense why you would use that for speakers, though.
Yeah, and the other reason they really like it is since it comes down, they can make it in such different thicknesses. You can make it pretty flexible.
Yeah,
and it still has some good strength to it, and so you can shape walls with it without having to put in a lot of slits, potentially to relieve those. Another good use for plywood, like the really thin, maybe 1/8, maybe 3/8. From what I saw, is you could make more curved shapes with it.
Yeah.
Where your plywood, you put a little slit in it to relieve, it'd probably just blow up. Or your OSB.
Yeah.
Yeah. That's why plywood's superior.
Well, it's cheaper. Mine.
See,
I prefer
the
inexpensive products.
The engineering world likes inexpensive products.
Are TJIs made with plywood in the middle or OSB?
Whatever.
OSB. Yeah. Huh. Well, could end on that.
But steel's better.
Steel's better. So I guess the call that you would get, when this comes up, for me at work, it was a contractor says, hey, do you care if I use OSB or plywood? And our drawings say some rating, structural 1, whatever it is. How do you answer that question? Because that's really what, got the information. That's what matters. I might start with, where is it?
So that's an interesting question. There is APA grading for plywood and OSB, and there is different ratings for weather. Exterior applications, construction, weather applications. There
is, but I don't know if I just read the wrong things, but I think I would still try not to use OSB in wet environments like the Northwest, places that could potentially pool water. I don't know.
So the Northwest is where I have all my wood experience.
Yeah.
And they used a lot of OSB.
Really?
A lot
There
of
was
OSB.
a big lawsuit in the Northwest in 95. And one of these one of these companies paid out $350 million in class action lawsuit. And this was really early in the OSB development, and things were just melting in the water. But it sounds like it was completely a detailing problem. They were holding moisture onto this, and it would just completely fall apart. But maybe if you are not, like how they had the wall system set up, I don't know what it looked like, but they weren't allowing moisture to escape. And
so maybe not leaving gaps around the...
Not leaving gaps. Maybe the, what's it called? What's that? The Tyvek paper you put on? Like house wrap. Maybe the house wrap wasn't permeable enough, and they weren't letting moisture penetrate through.
So the one issue I saw in the Northwest with OSB was on a multi-story building. I believe it was 6 stories over a podium, and they didn't put any building wrap on it, and so the water was coming down the whole face of the building. Now a lot of them didn't have issues, but there are some that puffed up and then bowed because they started expanding, and the 1/8-inch gap on each side that's supposed to be there was gone, and so all of a sudden the board started growing outwards.
Oh man!
Bowed the whole board or the whole sheet, and then the plywood that was on the building almost doubled thickness around the edges.
Yeah.
Or sorry, the OSB.
I would say, okay, back to this theoretical call here.
Yeah.
If the product was to be used indoors, I would say OSB 100% of the time. I see no reason not to. It is stiffer and it is more consistent. And the thing that people pick up with floor vibrations is inconsistencies. And you can have a sheet of plywood when you have these, knots that line up with each other that is less stiff than the next one, and you feel that difference.
I'd use an inch and an eighth though.
You can't just use more.
Yeah.
I
think there might be some validity to that. I think, though, going to floor, if we're really diving into floors, I think this is a super hot topic with condos and stuff. Is vibrations on wood floors. I think super thick plywood or OSB, or really, I think inch and eighth, which is almost that's a super stiff floor.
I just wouldn't want that variability in stiffness. You have a very consistent product with OSB. What you get on one panel is the same as the other, so you don't feel that difference walking across the floor. I
think it depends on a lot of things. I mean, what are your joists spaced at?
Their ratings on span are exactly the same.
I get the rating. I'm thinking through the vibrations. I think there's more than just the plywood that's playing, or the OSB. But if we're going just to that,
their mass is essentially the same. Let's say OSB is slightly heavier, which is good.
So I think that helps. That helps.
So negligible, right? Their stiffness is targeted at the same. So plywood tends to be a little bit stiffer, much like concrete tends to be a little bit stronger than it needs to be, because they need to cover that lower bounds.
Correct, yeah.
So you will have a stiffer floor with plywood, but 1 out of every 100 panels, or whatever it is, I don't know, is going to be softer, and you'll feel it.
Okay.
Yeah, I don't know.
Sure, I'll give you that. I would want my contractor to test out every panel.
Okay. Have him jump on.
So there goes another week of the construction schedule.
I think if it was for exterior, I probably, living here in Colorado, I'd probably say doesn't matter.
Well, as a house engineer, what did you
engineer? OSB. There were some
single family dwellings.
Yeah, OSB, but there were some. I mean, it definitely fit with the 70% that I saw.
Yeah,
there are definitely old school contractors that say plywood is real wood, OSB is fake wood, kind of thing.
What about tongue and groove?
Like thin or TNG plywood?
TNG plywood.
Oh,
you ever see that?
Yeah,
a lot.
Well, I don't lay it down, so I've never spec'd it specifically for any reason. Yeah.
I think that's an interesting topic because that doesn't allow, when you put down plywood and you give an 1/8 inch all around everything, that gives room for movement and stuff. And I've been wondering what happens with TNG.
Yeah, I don't know. Less movement, probably not a great thing sometimes.
Yeah. Depends. So can your building grow or shrink with fluctuations in humidity and temperature during construction?
Yeah. No, probably not as well, but
I think an interesting point.
It is an interesting point.
Yeah. It's all I'm full of is interesting points. Okay. One thing I read a lot of with plywood is that it is really good at not splitting when getting shot with a nail gun.
Oh. Like you can shoot through OSB easier? I've seen you can shoot through through OSB.
Yeah, if you're overpowered your nail gun. So plywood, that's one and done.
Yeah,
shooting it on, you're good. Now, if your house, money wasn't an option.
Money wasn't an option.
Yeah, an object. That's not an option either. But plywood, OSB.
I think if money wasn't an object, I would plywood the whole exterior and OSB the interior. Really, I'm sticking with that OSB on the floor thing, but I don't. I don't know. I just think I like that consistency.
Okay.
Your perfect house?
Plywood. Inch and 1/8 plywood everywhere.
And the studs are 4x4s.
No, it's way too small. 4x12 studs, 8 inches on center.
Yeah,
actually CLT panels the whole house.
That's a good point. Then
I don't even need a sheathing on it. Fun fact, real quick on CLT. when it was first being used in the market, it's still fairly new to the U.S. But some jurisdictions did not believe it had any lateral capabilities as a diaphragm. We're talking 5 to 12 inches thick of wood. So they made
5/8 OSB does.
So they made them sheath the whole diaphragm.
What?
And nail it down as if it was going to blocking or joist.
Wow.
Some jurisdictions were that scared to use it.
That's nuts.
As a diaphragm. Since they've done testing and
found it.
There's a lot of freaking wood to transfer loads through. Now it's super stiff. The issue right now is shear walls and figuring out how ductile they are. But
yeah,
it's a whole different talk. But
yeah,
that was an interesting point.
We're at about 30 minutes, and now we're starting to talk about other random stuff. So maybe that means
the podcast is over.
So yeah, thank you guys for watching, listening. Like always, reach out to us if you have any questions, any comments. We've got an email address. It is in the show notes. We've got Instagram. It's in the show notes. And
Facebook.
We've got a Faceplace. So come find us, and thanks for listening.
We'll catch you later.